Good morning. Today we're going to be looking at classifying triangles. Now, we looked at quadrilaterals yesterday and we tried to remind ourselves what they were. Triangles, I'm hoping we're a bit more clear about. We've done them for a few years. So triangles, 2D shapes with 3 sides. So we go straight on to question 1. It says, Ambika folds a square piece of paper in half, diagonally, and Lee folds a rectangular piece of paper in half diagonally as well. What shapes have they made? Well, there's the shapes they've made. So they have made triangles. Now the question is, question A should be straightforward, I think. Question B, how are the 2 different triangles similar and how are the 2 different? So how are they similar and how are they different? A bit like yesterday, we looked at quadrilaterals, how are they the same and different? We're going to do the same here. So if we look at the triangles, for example, let's look at the one that was a square and we folded it in half. What can you tell me about those triangles? Well, I know that the triangles have right angles. That's true, yeah. I know that they have acute angles, which we'll look at again in a couple of days' time. Now, what's different about them? How about let's go over here and let's have a look what they say. So, when folded in half, both the square and the rectangular pieces of paper create types of triangles, as we said. Now, here for B, as I said, both triangles have a right angle. But what else do they say? The square makes a triangle that has 2 equal sides and 2 equal angles. This is called an isosceles triangle. So let's highlight that one. Isosceles triangle. And the rectangle makes a triangle that has 3 unequal sides and 3 unequal angles, and it's called a scalene triangle. So that's this one here. 3 sides different lengths and 3 angles different sizes. Scalene. There is another type of triangle. A triangle that has 3 equal sides and 3 equal angles is called an equilateral triangle. So you've got 3 triangles here that they've given you. You've got an equilateral triangle with all equal sides. You've got an isosceles triangle, 2 sides the same. And then you've got a scalene triangle with none of the sides the same. Alright, that's 3 triangles. There is one more triangle called a right angle triangle, which is a triangle with a right angle. Okay, let's move to this question here. Question 1. Think which of these triangles is a scalene triangle? Now we've just learned that a scalene triangle is a triangle where none of the sides and none of the angles are equal. So we have to look here. So let's look at the first one. Here, that side and that side are the same, they're equal. And also that angle and that angle, they're equal. So that can't be a scalene triangle. Here, that side, and that side, they're all equal. And the angles, 1, 2, 3, they're all the same size. So that can't be a scalene triangle. So this side, and this side are all different lengths. And that angle, and that angle is different sizes. So that makes C the scalene triangle. Question 2. Which of these isosceles triangles have 3 acute angles? Now, we need to know what acute angles here are, and we also need to remember what isosceles triangles are. So there's isosceles, and here's acute angles. So first of all, isosceles triangles, if we remember from before, they are triangles where two of the sides are the same length and two of the angles are the same size. And then it says, which of these isosceles triangles have three acute angles? So an acute angle is an angle that is smaller than 90 degrees. So if I look for a 90-degree angle, I'm sorry I'm not using a ruler here, that's a 90-degree angle. So an acute angle will be an angle that is smaller than 90 degrees. So there's an example of one. There's one. Anything that's smaller than this angle here. This is your 90-degree one. Acute angles are smaller than that. Just to remind you. Some of you will remember that, but I'm not sure. Okay, let's have a look. So they're all isosceles triangles, but which ones have acute angles? So this one, that's less than 90, that's less than 90, and if you turn that around, that's less than 90. So an isosceles triangle with three acute angles, there's one. Let's look at the next one. That's less than 90, that's less than 90, that one is more than 90, so that has not got three acute angles. Let's look at C. That's an acute angle because it's less than 90 degrees. That's the same, they're both less than 90, and this one is also less than 90, therefore C is also correct. And let's look at the next one. Less than 90, less than 90, greater than 90. And the angles that are greater than 90 are called obtuse angles. Right, so that's not one. And finally, let's look at this one. Oh, it's just less than 90, and so will that be because they're the same. And that's a lot less than 90. So another example of an isosceles triangle with three acute angles. Okay, hope that makes sense. Question 3. How many different triangles can you make on a 3x3 or 3x3 geoboard? So these are elastic bands here. How many triangles can we make? Oh. Now if we were at school, it'd be good to try this out. Let's just give it a go without. So different triangles. Well, I'm going to try a simple one there. Then I'm going to try one there. I'm also going to try there's 3. For now you can try lots more. There's loads more. B. Have you found them all? How do you know? Well, remember the triangles are the same even if they're in different positions. If you turn your paper around, that could still be the same triangle. So if you look at these two triangles, for example, they are the same triangle. They're just upside down, or the other way from each other. So you'll be able to work them out if you used the pins here. You did a small triangle. Maybe if we rub this out, it might be easier. Okay, so if you did a small triangle, and then a longer triangle, okay, and then a even longer triangle, and then another one. Now if you tried to do that again, just move that there for a minute and then get rid of them. If you just turned it on its side, still give you the same answer. Still the same triangles but on their side, and the same again here. and the same again here. So they'd still be the same types of triangles, just like it showed down here, just round in a different way. So if you get them all from the bottom side, then you turn it clockwise, or you turn it 90 degrees each time, you'll have the same triangles, just in a different direction. Okay? Give it a go, have a play. Maybe try drawing 9 dots on a piece of paper, lots of 9 dots, and see how many you can find. It's quite good for a little investigation. Okay? Good luck.